Hello students, welcome to online lecture series of Discrete Mathematics. So now our today's topics are fundamental cut set and fundamental circuits. So before we start with fundamental cut set, we must understand that what is this cut set. So cut set is a minimal set of edges in the graph that then breaks the graph into two parts. This after cutting the edges, right? So the graph can be cut into two parts, right? So whatever edges involved in that, this nothing but your cut set. This is nothing but your cut set. So see here for this graph, whenever see the graph. So here, whenever we cut the graph like this, so graph is disconnected into two parts. This is one part and this is one part and this one is the second. This E1, E6, E4. E1, E6, E4. This is one cut set. Again, you can say, we can cut like this, right? So graph can be again disconnected two parts. That is, this is one part, right? And this vertex is another. So graph can be disconnected into two parts. So E5 and E4. E5 and E4. Same, we cut like this also. So two parts are there. Again, when we cut like this, so there are two parts. First is this one, this edge, and second part is only this triangle. Right? Because when you are removing these edges, right? So only this A to E edge is remaining, and here this triangle, right? So this is a cut set as E1 and E3, and whenever there is a minimal set of edges are there, right? Minimal set of edges. So minimal set of edges are E1, E3. There are two edges are here. Again E5, E4. There are two edges are here. So these are the minimum. So this is nothing but the cut set for the given. They are the cut set for the given. So for fundamental cut set, so here we have to remember every fundamental cut set contains exactly one branch of the spanning tree. One branch of the spanning tree. So in exam, right? So one graph is given and a spanning tree is also provided to you. So using that spanning tree, you have to find out the fundamental cut set and a fundamental circuit, right? So what is this branch? Right? What is this branch? Exactly one branch of a spanning tree. What is this branch? Branch means what? Whatever edges present in a spanning tree. Whatever edges present in a spanning tree is called as a branch. Right? So here, second point we have to remember, number of fundamental cut set is equal to the number of branches in a spanning tree. Number of branches in a spanning tree means every fundamental cut set contains exactly one branch, right? So whatever fundamental cut sets are generated, right? That fundamental cut set contain exactly one branch. That set contains exactly one branch, and whatever number of branches present in a spanning tree, that number of fundamental cut sets are generated. That number of fundamental cut sets are generated. You see the example. So this example, graph G. So graph G is given, right? So for that graph G, For the graph G, a spanning tree is given T1. This is a spanning tree. So for that spanning tree, see here. So number of fundamental cut set is equal to number of branches, right? So what is a branch? Number of edges present in the spanning tree. So how many edges? 1, 2, 3, 4. There is E1, E2, E4, E5. These are the branches. E1, E2, E4, E5. These are the branches, right? So how many fundamental cut sets are there? 4. So four branches and 4 fundamental cut sets. So whenever we consider E1, right, branch E1. So every fundamental cut set contain exactly one branch. Exactly one branch means whatever cut set is there, we have fundamental cut set. So E1 is a one branch only present in that cut set. So how to find out this cut set, right? So whenever this E1, whenever we cut this E1, right? So whenever we cut the graph using this branch E1, right? So there is only one branch and others are the chords. Others are the chords. So other chords means what? The edges which are not present in a spanning tree. The edges which are not present in a spanning tree. So whenever this is E1, so how to cut this graph that contain exactly this one branch E1? So we have to cut like this, right? So E1, E6, E3, E1, E6, E3. There's one branch is there. Yes, exactly one branch. Now there are the chords. There's E6 and E3, which are not present in a spanning tree. Second, E2. So when we consider E2, whenever we consider this E2, this is E2. So how to cut this E2? We cut like this, right? Whenever we cut like this, right? How many branches are there? Only E2, and other are chords, that is E6 and E3. E6 and E3. So fundamental cut set containing E2, E6 and E3. Then next E4, right? E4. So with E4 branch, with E4. So this is your E4. So how to cut this E4? Like this, right? So E4 and E3. E4 and E3. This is your fundamental cut set. E5. For E5, so E5 cut like this. It's E5, E6, E3. E5, E6, E3. There's only one branch E5, others are the chords. Others are the chords. So remember, we can't cut like this E4 like this. Why? Because whenever cut like this E4, there is E4, E6, and E1. E1 is a branch. And as per, right, as per the our definition of fundamental cut set, there is only one branch must be present in a fundamental cut set. Ready? So next, there is fundamental circuit. So number of fundamental circuit in any spanning tree is equal to the number of chords of that spanning tree. Number of chords of that spanning tree. Fundamental circuit, so fundamental cut set, number of branches is equal to fundamental cut set. Here, number of chords is equal to fundamental circuits, right? So what is the chords? Chords is nothing but that is a number of edges. So the edges which are not present in a spanning tree is called as a chords, right? So here, this is a graph G and this is a spanning tree, right? This is a spanning tree. So how many chords are there? The number of edges which are not present in a spanning, the number of edges which are not present in a spanning tree. So this E4 and E3, E4 and E3 are not present in a spanning tree. So these are the chords. So E4, E3. So number of fundamental circuits are only 2 because there are 2 chords are present. So with respect to the fundamental circuit with respect to E4, right? So E4, this is E4. So fundamental circuit with respect to E4 are, right, means here whenever we add this E4, right, whenever we add this E4 in this spanning tree, one circuit is generated here, right? This circuit, one circuit is generated. This circuit is nothing but your fundamental circuit. That is E1, E5, E4, or E1, E4, E4. Getting? This is a fundamental circuit. Same this E3, using this E3. So how many? Using this E3. So this E3, whenever this add E3 in this spanning tree. So again one circuit is generated. So this circuit, right? So that is E3, E2 and E5. E3, E2 and E5. So this is your fundamental circuit. So we stop here. So next lecture we will see the next part.